To introduce our speaker today is Rupert Cutler.
Well, thank you, President Reggie. We're very fortunate today to have as our speaker the president of Virginia Transformer Corporation, a major local employer. Andy Stone, our vice president, has been anxious to have speakers before us from our business community, and we're pleased to have a perfect example of that with us today. Mr. Jain has degrees from in mechanical engineering obtained in India, an MS in material science from Villanova in Pennsylvania, MBA obtained in Lynchburg in 1981. He began his career in 1965 at Hindustan Motors in India as a machine shop foreman in a auto manufacturing plant. From 1977 until 1982, he was with General Electric Corporation, starting as senior design engineer and later design manager of the variable speed drive system manufacturing program with GE. He serves on the Virginia District Exports Council and was chair of that council for 2 years. He's been on the United Way Board, the Roanoke Chamber of Commerce Board, the Virginia Manufacturers Association, the Jefferson Center, and several professional associations. He's been a generous supporter of local charities, recently set up a scholarship for area high school graduates. Please welcome Virginia Transformer Corporation President Prabhat Jain.
Thank you very much, Rupert. Thank you very much for the opportunity to speak in front of this distinguished group. Seems like a fun organization, all the things I've seen here so far. And certainly you're serving the community, which is even makes it more deserving to be able to speak here in front of the group here. So thank you very much for the introduction, Rupert. I've been in Roanoke Valley since 1977. So I've lived here almost 40 years, 2 more years to go. And we have enjoyed living in Roanoke entirely. All of our kids grew up in Roanoke, 3 girls. And they were educated here in the public school system. And then, I've been working at Virginia Transformer since 1982. So that's a long, satisfying career, and we have had a lot of growth, and we will just talk about it a little bit. But before I go there, I just wanted to mention a little bit about what's happening. We all know about the oil price. So I just wanted to calibrate, because that's one of the things we do, is to look at economy and industry as to how things are going in the world, and particularly in North America, US, Canada, Mexico. So as you know, the oil price, we all know, we buy gasoline at the pump, and it's less than $2 a gallon. But I do remember when it was 29 cents a gallon, so we're not there yet. So it's, it's $6.70, $80 right now. However, the story is the oil being less than $30 a barrel, which was not too long ago $60 a barrel, and then it peaked at about $135 a barrel. And back when it was stable, in the good old days, it was less than $10 a barrel. So at any rate, so economy has made a huge swing with respect to handling the high price of oil, not only United States, but the rest of the world. The U.S. is fortunate because we were producing about 35% of our oil here about 20 years ago. Today we produce 50% of our oil in our country. So we have reduced our import bill by significantly, and also dependency on the other foreign countries for import of our energy source. At any rate, so now this is a huge swing, as of course we all know, in the economy and the industry, but yet it has a, 2 sides of it. Of course, the people who produce oil, which are the integrated oil companies, their resource value for the oil in ground has gone down. However, on the other hand, they are refining and producing chemicals and then lubricants and rubbers and those kind of things, and they take the oil as the raw material, and that raw material price is going down, so their income on the other side is going up. So overall, there is a slight net negative effect, but not that great, really, as far as U.S. is concerned. And then the rest of the world, of course, people who don't produce oil, it's a huge tax reduction, if you will, for them, because their tax bill, their oil bill is going down, so they have more money to invest in the infrastructure. Countries like India and Pakistan and Indonesia and many of the other countries that have huge populations. At any rate, so that's the kind of background. Of course, we look at these things very, we live in the world, so we pay attention to them and what's happening and what it means for our business and where we are going, etc. So I want to thank you very much again, President and Rupert, for the opportunity that you have given me. And then Thomas organized it for us. So again, thank you very much, Thomas. So with that, I will start. And then, so I'm going to talk a little bit about Virginia Transformer as to who we are, what we do, and what does a transformer do in the industry? How does it relate? What is the role of Virginia Transformer in the Roanoke community? First of all, it's closest to us. And also what it means for the national economy, and then how we play a role in making the United States as a stronger industrial power and its GDP growth. So this is what the transformer does. So if you would see at the top left hand is the generating station, which generates power, and it could be a thermal. This one happens to be a thermal power station. And it generates power typically at 18,000 volts. So you see that transformer, which the arrow is pointing to, and then that transformer steps up the voltage of the electricity from 18,000 volts to, let's say, 500,000 volts. And the reason for that is when electricity is raised in voltage, its current is coming down, and it's the wire on which it travels can be reduced in size. So the cost of transmitting on those towers the power to the consuming centers, such as Roanoke, comes down. When it comes to Roanoke substation, let's say in Troutville, then the voltage is reduced from 500,000 volts to something, for example, 115,000 volts. And that 115,000 volt then is carried over to the, let's say, substation in Cave Spring, and that steps it down to about 15,000 volts, and then from 15, it then goes and goes to your home or industry, and there it is stepped down again. So it's good for us that we have to step it up and step it down many times, so it takes a lot of transformers. So when they produce 100 megawatts of power, it takes about 500 MVA of transformers. So that's how the industry works. So this is a transformer, and it's a liquid type transformer, which is most of the large transformers are liquid filled, so they're oil filled. It's a mineral oil which is derived from petroleum, from crude, basically. So this is a transformer. As you can see on the front side, there is some panels which are used for cooling, because the transformer produces a heat, and that heat has to be dissipated through those coolers. We call them radiators, just like your car radiator. And then on the left side, there are some other parts here, which is controls, monitoring, other equipment, etc., in order to monitor what's happening in the transformer. And in this transformer, looking at the size of this, appears to be probably around maybe 20 MVA size transformer. Now, the heart of the transformer is a winding, which is the coil, which actually carries the current and is able to change the voltage. And then that's the heart, and that's where the maximum skill level is needed in order to wind a reliable transformer, which requires a reliable coil. Now, this is all hand done. So you can see the machines which turn, but the winding and these turns that you notice are put on by hand. So people are holding the wire in their hand. It's passing through their hand. As it passes, they need to feel if the wire has enough insulation. There's no nicks, there's no burrs, and then it is a good quality wire that's going into the coil. And then, as you can see the picture on the lower right-hand side, that's the neat-looking coil, And you see crossovers, so it's going from one disc to the next disc. It's a very laborious and in a very highly skilled process to wind coils. And we have in Roanoke, we have about 40 people that wind coils like this. So then we need to fabricate a tank into which the coils and the core will be then lowered into the tank, and it will be filled with oil. So these are the essential components of a transformer. Now these are the monitoring devices, because transformer has a lot of energy, and if something goes wrong, it will create a lot of it can create a lot of heat and an explosion, etc., because it can get very hot. So to protect and to monitor what is going on, there are many gauges. So we monitor current, we monitor voltage, we monitor pressure, and then we monitor temperature in the coil at many places. And all those are monitored and brought to a junction box, which you see there. I don't know if it's reached there or not. On the left side, you see a stainless steel box, and that has in it devices which are monitoring it, measuring it, and then it is connected to the owner's, like a utility substation monitoring station, and they monitor all the parameters such that they can have a transformer operate at safe level. Sometimes the transformer gets overheated because the load goes up for some reason. And then, of course, they have to divert the load, which is what the control room operator would do. Then, of course, each transformer is tested to very, very high voltages. So, for example, we can produce voltages up to 1.2 million volts to test the transformer. So each transformer has to be tested entirely 100%, because it is a high voltage, high power device, and then nothing should go wrong when it is in service, because it is providing power for residential areas and also for industrial areas. So it is tested entirely, and there are many, many different types of tests. Some tests are there performed only to verify that it is built reliably, and then everything is going to pass, or it's going to pass the industry standard. But even beyond that, then we do some testing, which is sort of the signature of the transformer, and that SFRA test that you notice there is one of those tests. And then when it travels over the road, maybe in rail cars, then it can sustain some damage. So at the other end, we again perform an SFRA test, which then compare the signature, and we can see if everything is okay or was there any damage. Then we have to monitor and we have to address that. So these are the industry standards, and ANSI is our American National Standards, and this is the most prevalent standard here in Canada, Mexico, and United States. ISO is the quality organization. All our plants are ISO certified. UL is safety, and that ISN is a membership that we have, so we can quote our transformers in all parts of the Canada and the United States to the contractors. IEC is the sister organization of ANSI. So IEC is in Europe, and then ANSI is USA. So we perform to all these standards. This is a brief timeline. The company was set up in 1971. I came into the company in 1982. And in 1989, we moved from Cybele Drive to where we are now on King Street. And then 95, we built a plant in Mexico as our growth continued. And then in 97, we achieved our quality ISO certification. And in 2003, we purchased a facility in Idaho, which makes larger transformers than what we make in Roanoke. And in 2013, we built the Troutville facility here to build tanks, because we were growing and we could not continue to do the work in the Roanoke facility, so we built a new plant there. And in 2015, we added our fifth facility, which is a plant in Georgia, in Savannah. So altogether, VTC facilities have 500,000 square feet of production space, and then we have 1,100 employees in the 4 plants, manufacturing plants, and of course the 5th is the fabrication plant in Troutville. So this is the corporate office on King Street, and then it has the offices and also the production shop. This is the Troutville facility where we have robotic welding, CNC machines, automatic painting, and then sandblasting systems. So we produce these tanks which live in the outdoor environment for 25, 30, 40 years, and then these have to be there for a long time, and they should perform without rusting. So this is almost like a car painting system is the level of the paint that we put on our on the tanks. This is the facility in Pocatello, Idaho, and this is a very large plant. It's about 180,000 square feet, and we can build transformers there up to 150 MVA. So they weight, just to calibrate us, they weigh up to about 250,000 pounds, namely about 120 tons, somewhere in that range. Those are the transformers produced in Idaho. And those transformers are used in power stations, in wind farms, solar farms, and also they are used in large industries like steel mills, paper mills, and cement plants, and then also in our defense facilities. This is a plant in Chihuahua, Mexico, which we built in 1995, and that's a plant which is 75,000 square feet, and then that's the plant we built to build our smaller transformers. So these transformers are roughly around 10 MVA. By the way, 1 MVA can supply transformer with about 200 homes approximately. So a 10 MVA transformer will supply about 2,000 homes. So they still are fairly large size transformers. This is the latest plant that we purchased at the end of 2014, and now it is integrated in the VTC family. And that's the largest, 225,000 square feet. More importantly, this plant is the best equipped transformer manufacturing plant in North America. And also it is the largest, and it can produce the largest transformer in North America, namely about 1,400 MVA. These transformers at that size are used for very large power station, generating stations such as nuclear, or it could be hydro. Only those plants go that large, 1,400 MVA. And then that's the, it has a huge capacity. Its test bays are 80 foot high because of the highest voltages that we have to apply, so we need a lot of height in those plants. So these are the markets we serve. We are completely versatile in serving any need for transformer in industry and utility across the board. So we are complete service provider, transformer provider in the country, broadest product line. So we serve renewables has become a large segment of our business. Renewable energy, green energy, wind and solar and hydro and then bio. Then of course the utilities, which are the companies that produce electricity like AEP and Dominion, etc. And then of course they transmit to the consumers such as the residential or the industrial areas. Now the industrial area of our business is very, very vast. United States is a very large country, huge installed base of industries. There's steel, there's paper, there's cement, car manufacturing, and then aluminum and plastics and fertilizers and everything. So we serve all of those industries from our transformers, from our 4 plants. Commercial area is of course very important. We have transformers in the FBI building and some other places, but that's a very broad area for us. We serve that through contractors. The last one I mentioned here is the transit. which again leads to green environment. And we have been serving transit industry since 1977. So we are the leading transit transformer supplier in the country. So on the utility side, we supply transformers for, in that first picture, for where the power is generated, we supply that transformer, and plus all the others that step down the power. We don't supply the transformer which is in your home or outside of your home. It's too small for our range, but we stop at the, let's say, the Cave Spring, substation. So we don't go smaller than that. So Florida Power and Light is a customer, Dominion Power, and then Duke Energy in Montana, Dakota. Obviously, you can, all the fracking activity that's going on in Wyoming and the Dakotas, we have participated in that for the last 8-10 years now, so that's a very big market. And even though the oil is slowing down, but we're still selling transformers to utilities in Montana and Dakota because they're still serving the fracking field which are there, and they're producing oil. Mining is another big sector for Virginia transformer. So we serve the mines where you mine the ore from under the ground, or you mine the ore on the surface. And then of course, you have to remove the ore and you take it to a crusher, a ball mill or something like that, and then you process the ore. And every time you do that, it takes power, and power takes transformers. So transformers are used across the whole spectrum of extracting the ore from the ground, and then up to the point of smelting it and pouring it to ingots so it can be transported to mills for further product making. So Rio Tinto, Freeport McMoran, and BHP Billiton, those are the largest mining companies in the world. Over the period of time, all the consolidations happen, and they are the three largest ones, and we serve all of them. And then, of course, iron, aluminum, uranium is a big part of the business that we serve, gold and copper. And then, of course, there is coal, even though coal is declining, but it's still very, 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 very large. Huge amount of coal. So not only, we are using less coal in our power production. However, we are still exporting a lot of coal to other countries. I'm sure you see all the coal trains, going through here, through the Roanoke rail yard. That is all going to Norfolk for being exported. So we serve coal mines in West Virginia, Kentucky, Illinois, and further west. And of course, we serve all the areas of mining in North America, South America, and Peru, and Chile, and then Australia. Oil and gas is a huge sector. As I mentioned, we are now 50% self-reliant in producing our oil and gas energy, and then it is continuing to grow. And the oil fields in Pennsylvania are huge, and they're still just coming online. So I think we're going to produce a lot of gas. All the consumers are benefiting. The gas price is down to about 15% of what it used to be, some 25, 30 years ago. So hopefully you have gas heating in your home, so you are benefiting by that. So which most of us do. We provide right now we have so much gas that we're going to start exporting gas, and we were allowed as a country. The Congress has legislation so we can export gas. So only until about 10 years ago, we were importing gas, and we wanted to liquefy, or liquefied gas was coming to the Gulf Coast, and from there we were distributing it in the country. And now suddenly we found so much gas in our country that our price declined, and now we are exporting gas. So we had to soon turn around those import terminals into export terminals, and we are supporting about 2 of them right now, and there are 3 more export terminals being built in. One is in Savannah, and then the other 2 are in the Gulf area. And then so we're going to export a lot of our gas. Right now, we can't use the gas that we have, and then we are flaring it, so which is not good. So we're going to start exporting it over the next 5 to 10 years. So we will get a lot of revenue, and then and a lot of commerce will be developed with that. Also, then all this gas and oil that has to move in pipelines. In the gas, you compress it to move it. in the oil, you pump it to raise the pressure to move it. So we supply transformers for all of those. These are massive, operations, massive. I mean, some of these compressors for gas can be 20,000 horsepower. So they're huge. And then, of course, when you start liquefying gas, you have to certainly compress it a whole lot in order to make a liquid. And then these are very, very large operations. Thousands and thousands of horsepower is used for moving the oil and the gas through miles and miles and miles, large countries, so we move it lots of miles. Then, of course, then we make, in our country, we make plastics and other chemicals out of the oil. And then again, those are huge facilities, Lake Charles in Louisiana, Geismar in Louisiana, all the Houston area. It's full of plants. I'm sure you have traveled across the country. There you see, miles and miles and miles of plants, and that's huge industry there. So we provide transformers for all of those industries from our plant in Mexico and also our plant here in Roanoke. And then, of course, the refineries and offshore platforms, those are huge operations. The offshore platforms are as large as a football field. And then they require a lot of power just to keep them balanced, because there's a lot of waves, and those waves try to unbalance it, and there's people working on there. Helicopters have to land. So they have a very elaborate system where they pump water in like 6 reservoirs, and they keep pumping it back and forth to keep it level. And all that takes a lot of power. They generate their own power on the platform, and then we handle that power with the transformers and into the machinery that handles those pumps. So refineries and offshore platform is very large business. We work with people like Bechtel, Fluor, KBR, CBI. These are some of the very, very large EPCs. These are engineers, procuring, and constructors. So they are engineering firms that buy transformers, and they supply a whole turnkey package to their client. And these are some of the clients. Of course, you know the names. So we serve everybody in the oil industry. Pemex is the Mexican state-owned oil operation. And of course, some of the others. So then, of course, now the bright spot in the country, as you know, in Paris, they just signed the limitation of the the gases that cause global heating, which is CO2. And then it's very interesting that 116 countries of the world signed up. And that's very, very optimistic. It's very encouraging that all these countries have signed up to limit the production of these hot gases, or gases that make the environment hot, and then to limit the temperature rise of the waters to 1.5 degree over the next 50 years. That's a small number, but it's a huge number when you look at the coastal areas where the water is going to rise because of the global warming. So, and of course, our President, Mr. Obama, has committed that a lot of money for as an incentive for people to grow and then develop these energies, and then we are going in that direction. So we supply 10% of the transformers for the alternative energy last year from our plants. And then this is just a conversion. 100 MVA produces or supplies 20,000 homes. So these are very, very large plants. We have some sizes. We'll come to that. So these are just some pictures of projects. We did supply the transformers, the big dig in Boston. And then, of course, that's a refinery, Sabine Pass. We have transformed the Yokohama plant in Salem and the cancer center at the hospital. These are some high-profile installations, Washington Metro. All transformers are from Virginia. They're made, some here in Roanoke, some are made in Mexico. The Tower of Terror in Disney World, in Orlando has our transformer. The New York Casino, Detroit Airport, Trans-Canada Pipeline is a huge pipeline system, goes from almost half across the country there, and that has our transformers. Export terminal, the K-Wind wind farm in Kansas is 360 MVA, huge, 75,000 homes worth of electricity they produce there. And then, of course, there are many other wind farms. So what's our role in building a strong industrial base for United States? Reliable electrical power grid. It's a huge effort underway. It's going to take probably next 30, 40 years to achieve the reliability of the power grid so we could share the power across the board and then have reliable power for all parts of our country, for residents and for industries. Oil and gas energy self-sufficiency, we are fast moving in that direction, and it's very important. And then we have a lot of energy with fracking technology. We can produce oil just about anywhere. So that's very good technology. Renewable energy is again available, and it's growing. There is a huge incentive from the government to produce the energy, and then we are going in that direction. So then we have, of course, the reliable industrial solutions, which are heavy industry and construction. So this is the recognition that we got from the local newspaper that, we are playing an important role. So we are a global company. We have transformers in all these different areas of the world, and then we service them. They are reliable, and then we are building pretty much, of course, all of our transformers are I would say about 80% are in US and Canada, and then the rest of the world. So that's a big picture here. I see Mr. President standing up and then giving me a signal here. So thank you. Thank you very much.
Mr. Jain, we want to thank you for your presentation today and for being with us. He will be available for a few moments after the meeting if anyone has any questions. Next week, our speaker is Appalachian author Michael Abraham, who will be introduced by Rupert Cutler. If everyone will please stand for the benediction, we'll get out of here on time. Having passed through our regular order of business, we are now prepared to leave this time of friendship and fellowship to re-enter our everyday world. Before we depart, let's try and remember three things. First, to extend to every person we encounter the same kindness that we as Kiwanians share with each other. Second, let's be ever vigilant for ways to better serve the elderly, the downtrodden, and the young people of our community. And finally, let's take every opportunity to share the day with those with whom we sympathize and deem worthy of our regard. If we can turn these ideals into actions, we will truly begin our way in building a better tomorrow. Live life, laugh loudly, recruit members, and start thinking about KPAD. This meeting of the Kiwanis Club of Roanoke is now adjourned for the next 167 hours, and we'll reconvene next Wednesday, commencing at a few ticks past high noon.